Welcome to TXAPA Live. My name is Jim Warren. Glad to have everybody here today. We are ready to get started. We are continuing our program on fundamentals this spring or this winter. And we are pleased to have Chuck Fuller here today. And Chuck's going to continue the fundamental series. So Chuck, welcome aboard.
Well, thank you, Jim. I really appreciate it. And like Jim said, we're going to continue the series on the fundamentals. What we've learned in the past is that no matter how complicated things get, if we don't have the fundamentals down or the basics down of whatever we're dealing with, we're going to just be spinning our wheels. So that's what we decided to do at TXAPA this winter, is to go back and let's reevaluate the fundamentals. A couple of weeks ago, 3 weeks ago, we talked about aggregates and the structure of aggregates and how that was going to work. We had Richard Izzo come in with materials and tests, talk about frictions of aggregates. So that kind of followed our aggregate. We had Robert Lee was supposed to be on during the winter Armageddon thing that happened last week, and we were not able to have that, so Robert's going to come on later on. But Robert's presentation was going to talk about how to design friction for aggregates, and Richard's was actually the friction of the aggregate itself. So we're kind of going through the aggregate side, and now that we've done the aggregate side, we're going to go into the next component, which is going to be liquid asphalt binders. And so Jim's going to help me. We're going to go through the liquid asphalt binder section of this. By the way, I am not a PE. I do not have all those things behind my name. I'm going to go through the basics, okay? The basics of liquid asphalt binders. I'm not going to get into the weeds. That's for you smart guys.
More than hot, black, and sticky?
yeah, it's the glue. That's all I'm going to refer to it. It is the glue.
There we go.
But it is very complicated. It is very detailed. There's a lot of moving parts, but we're just going to go through the basics because you can't get to the moving parts and to the detail until you understand the basics. So we're going to get this thing kicked off. So Jim, you ready?
Yeah, let's go.
All right, let's make this thing happen. So again, this is our asphalt pavement fundamentals. Liquid asphalt. Again, it's TXAPA Live, and I really appreciate the fact that I'm being able to do this with you guys. And I'm glad that Jim's here with me in case I stumble or fall down. He can pick me up. He's smarter than the average bear.
There we go.
So that's exactly right. So my advancement deal here
to the right,
right, bloody well right.
There
it goes.
All right.
All right. So let's go back. Definition of asphalt. So for all of y'all that looked at or saw the aggregate portion, we're going to just simple terms. It's a mixture of asphalt binder, graded mineral aggregates, mixed at an elevated temperature, and compacted to a uniform, dense pavement layer. Okay? That's all that is. That's the definition of asphalt. And so the components, again, this is the same slide as we talked about earlier. We got some issues there.
Slow down,
Let me come back down here.
Easy on the trigger.
That was a trigger happy there. Let me come back here. Trigger happy, still trigger happy. Coming back. Here we go, guys. Y'all saw the whole presentation within
38 seconds.
All right, so here's our components, right? So I want everybody to remember this picture, okay? This is the component picture. What do we have? We have liquid asphalt binder surrounding the aggregate. We have the mineral aggregates, and we have air. That's all it is. That's all asphalt is. And Buddy Williams was really nice to me the last time I was on here when I said that my dad taught me about the engine with you need fuel, you need spark, and I forgot to say air. And thank you, Buddy, for reminding me. My dad would be disappointed in me, but you need air. Okay, you got to have air for this to work. Okay, so we have the mineral aggregate that we talked about, and now we're going to talk about the liquid asphalt binder. So from a volumetric standpoint, this is it volumetrically. Okay, and we got mineral aggregate, it's going to be 85 to 95%, and then we have some of absorption from the binder, but the binder is going to be 3 to 8%, and then we have our air. And again, remember this because it's real important when we get back to the basics of what we're dealing with. Okay, asphalt binder. So where does it come from? Where does our asphalt binder come from? Well, it comes from a barrel of oil. And that barrel of oil is brought to a refinery, and it's put into these distillation towers. And it's not important to know what all these towers do. What is important to know is that as the lighter ends of the liquid asphalt, or the oil get distilled, we get heavier ends at the bottom. So our heavier ends, if you look at this diagram on the right-hand side, the heavier end, the bottom of the barrel is asphalt base.
That's where the asphalt lives.
That's where the asphalt lives. And the only reason this is important is because you got to realize that we're taking away the light ends. The light ends of that barrel are gone, okay? And we're dealing with the bottom ends of that barrel. And that's going to be real important when we talk about temperatures, okay? That's where that's at. That's the only reason that I have this up here, so that you know that we're at the bottom of the barrel. We're dealing with the heavier ends. So what exactly does that mean when we deal with the heavy ends? So here's our liquid asphalt components. We got our light ends, which is our saturates, our olefins, our aromatics. And then at the far end of that, you got your asphaltenes, which is the hard end. Okay, so when you take a look at all that, the light ends are your maltenes, and then you have your asphaltenes. And again, the only reason this is important is when we start dealing with temperatures. When we start making actual asphalt and we're dealing with temperatures, the higher the temperature, the more we burn off these light ends. And we heard the terminology, oh, they burned that asphalt up. They burned it up. I could smell it. Well, that's exactly what's happening, is that you're taking the light ends out, and all you're dealing now is with the asphaltenes, which is the very, very bottom of the barrel, and we don't want that. We want the components all to be together to be able to act properly, okay? And that's what it's all about. What's really good to know here is that not all asphalt components are the same, okay? In other words, both of these diagrams do meet a PG 64 minus 22, and we'll get into what that means here in a second, but they both meet the requirements. But if you look at them, one over here on the left has 68% aromatics, and the other one has 61%. And the one on the left also has 20% resin, and the one on the right has 17%. Yeah, Jim?
You know, and that's just because where the crude oil came from.
That's exactly
and there
right.
are, you know, hundreds, if not thousands, of sources of crude oil across the world, and a lot of that ends up here in Texas. And some crudes are better suited for asphalt, and some are not. But you know, we get a variety of binders here. But as long as they meet the end properties, that's really what we should be looking at.
That is exactly right, and it's not all the same. So it's exactly right. And that's one of the things that you just got to be aware of when we're dealing with liquid asphalt binders. So let's talk a little bit about what PG means. PG means performance grade, okay? That's what PG means. So when somebody says PG binders, they're talking about performance graded binders. And performance graded binders are normally used for the production of asphalt mixtures. So embedded in the PG binder nomenclature are the temperature extremes under which the HMA pavement must perform. In other words, resistance to rutting, fatigue, and thermal cracking. That's what PG means, okay? Is performance graded. And this all came about, I guess, during the super pave.
Yeah, the sharp research back done in the 90s, and this was a big element of that whole program.
And this nomenclature is used throughout the whole United States, okay? This is not just subject to Texas. This is used throughout the whole United States. And again, it's a temperature extremes. So exactly what does that mean? Here we have PG 5828, 64 minus 22, 64 minus 28. And what that is, it's a temperature in Celsius on the extreme grade. So it's 58 degrees Celsius minus 28 degrees Celsius.
Right.
That's the temperature of the pavement that you're going to be dealing with, right? Most of Texas, and we're talking about base grade now, most of Texas, the base grade is 64 minus 22. We have a few places up north that will differ from that. They might be a 58 up north, but most of Texas is 64 minus 22. And that's an unmodified. That's our base grade.
Yeah, and you're going to go into a lot more on the whole modification process as well.
Absolutely.
Yeah.
So what's neat to know about this is that they go in 6-degree increments. Okay? They go in 6-degree increments. If you look at it, it's 58 to 64, 64 to 70, 70, 76, 22 to 28. They're in 6-degree increments, okay? So when you get in to this modified, you see where it says modified at? If you get into the modifieds, that's going to be your 70s and your 76s, and we'll talk about how to modify and why to modify here in a minute. But the unmodified, the base throughout most of Texas is 64 minus 22, and that's going to be important when we get to the chart here in a second. So, come on, mister. There we go.
There you go.
All right. So, when we talk about the temperature requirements, it's the average 7-day maximum pavement design temperature is the high number. That's the big number. We're going to call that the big number. The little number is the minimum pavement design. Okay, that's the minimum. The big number, it relates to rut resistance. The little number relates to crack resistance. Okay,
It's always a balancing act. And the cracking side, finding something that's stiff enough, but not too stiff in the temperature extremes. And we sure have had some temperature extremes this last week.
Yeah, we were definitely and that's the average 7-day maximum temperature. I don't believe we got above freezing for 7 days.
For a couple days there.
Yeah. So, and by the way, this is the average maximum. Okay, average. It's not the one event. But again, Jim's right. We need to balance that fatigue cracking and that rutting. Okay. So remember, the big number is for rutting. The little number or the smaller number, which is a minus, that's a negative Celsius, that is for cracking. And so why do we modify? Why do we modify? We modify because of pavement durability. We modify to increase the serviceable temperature range, with stiffen or soften areas. It also improves aggregate asphalt, improves asphalt film thickness. And again, we're going to reduce rutting, cracking, raveling, bleeding, and improve the life cycle costs when we modify. Yeah, Jimbo?
We rely pretty heavily on that binder to do a lot of different things.
Absolutely. There's only 3 things, again, in the asphalt. It's the aggregate, the binder, and air. So the binder we rely on quite heavily to be able to hold the structure, to be able to make it durable, long-lasting. So that's the reason why we modify. So let's talk about modification of the high number, the big number, okay? We're talking about the big number here, okay? And why too? It's, again, dealing with rutting. We want to do it, address it because of climate, okay? If we have extreme climate issues, we want to modify it for traffic. If we have high traffic, we want to modify it if we have stops and starts, in these intersections that have a tendency to rut. Also with turning of traffic, and then localized in the pavement structure, if we need to be able to make that pavement structure more durable, we're going to modify it. So how are we going to modify it? We're going to use these latexes and the SBS. We're going to use styrene butylated styrene. We're going to use RAP and RAS, which is a recycled material. And then we're also going to be able to use PPAs. And there's more modifications available out there. We have some really high modified binders where we have this high traffic or high turning and stopping. I think the DFW airport was a 82.
Yeah.
I think the high number on the DFW airport is 82. And the asphalt at the track, at the F1 track, the high number was 82.
Yeah.
And it was because of the fact that they did not want rutting in the turns. They wanted those turns in that airplane not to be able to rut, right? So they increased that big number to adjust for rutting. And the way that we know that we're increasing that big number to adjust for rutting is through test. And we have so many asphalt liquid binder tests available to us. But essentially, what we're trying to do is establish a material that's not going to rut, but yet still be durable and not be and have crack resistance. The most common test that we use is the Hamburg test. That's the most common one that we use. And again, it's to identify material that's going to strip and rut. And that's the reason why we modify on the high binder or the high number. The low number, the little number, the minus number, again in 6-degree increments. is adjusted for climate, once again for climate. So Jim and Corpus, we're going to be the minus 22. Up in Abilene, where we'd be?
Well, at least a 28, maybe even a 34, but I think that's mostly a 28 up that area.
28, yep, a minus 28. So it depends on where you're at in the state, where that minimum number's at.
Mm-hmm.
And again, we're going to adjust for traffic, we're going to adjust for base conditions, and then the use of recycled material. And again, the location in the pavement. When I say location in the pavement, is it in the bottom course or is it in the upper course? That's going to be a determining factor. And we're going to get into that in just a second here. And again, the way that we're going to change it is we're going to use a softer base binder. We might use a rejuvenator, and they might use reobs, which again, TxDOT has now disallowed all reobs.
No moss.
Absolutely.
Yeah,
no more reobs in the binder. But again, we're going to use a softer binder to be able to adjust for cracking. And then once again, we have test. We have test to be able to determine that. And the most common or the most common test that we use for cracking is the overlay tester. That's the one that we've used and successfully have used to identify material that's not going to crack. So again, we utilize testing parameters to determine whether or not we're going to meet this lower end to prevent the cracking.
Yep.
Okay. So why different grades? Here's a softer grade. Why do we want to soften it up? It's because we're going to add stiffening. We're going to add wrap and RAS, which is going to stiffen the material. We just know that through oxidation, that recycled material is going to stiffen the actual mix design up a little bit. So we might want to soften it so that wrap and RAS reacts, with the material to be able to give us a good binder grade. And why do we want to stiffen it? Why do we want to have that big number, higher? It's mainly because of traffic, intersections, stop and go, that kind of traffic, heavy truck traffic, airplanes.
Yeah, and the traffic is increasing every year. I mean, we're looking at a project out right now out in Odessa that's got tremendous loads, just unbelievable loads from what you would consider just a few years ago.
Absolutely. And that's a good point. That we're not going to get any smaller, guys. We're going to go bigger. So it's important that you design engineers use the correct data to be able to determine which grade of asphalt to use. And we have a chart here that we're going to go through in a second. But it's real important to get that traffic data correct. Again, we would have never guessed where we're at today up on 35 or up in Odessa with the truck traffic. Okay, but it can successfully be used when we have the right information and we use the right grade of asphalt, liquid asphalt, and we use the right combination of aggregates that we talked about earlier. Again, understanding the very basics of it, right? So this little chart here is called the performance grade recommendation with 98% confidence. As a matter of fact, this is a spreadsheet. It's an Excel spreadsheet. Mm-hmm. You could put your latitude, your longitude, and you could put where you're at, and it's going to tell you with 98% confidence what your base grade is going to be. And again, if you notice, most of Texas is in the 64 minus 22 range, okay? We do have some areas where it's 70 minus 22. And again, we do have a 64, 34 way up there in the panhandle.
Way up there.
Very isolated though, but most of Texas is 64 minus 22. So that's important to know for your base grade. And again, this spreadsheet is available on TxDOT's website, and they use it all the time. Designers use it all the time to make sure they get their base rate or get their base grade right, and then they're going to modify from that. All right, so here we are. This is the chart that we're going to talk about. This is called the grade adjustment options, okay? So again, this chart, or this layout is available. It's on TxDOT. This is what TxDOT uses. And so we're going to start by selecting the grade from the climate chart. That's how we're going to start that. So again, we're at 64 minus 28. So let's look at the big number, the one on the left. The big number on the left. What's the very first thing we look at? Is the traffic volume. Now, this is the projected traffic volume that you're designing for. It's not the volume that's happening today, because we know that it's going to get worse.
Absolutely.
Right?
Yep.
So we're going to project. So if you have between 10 million and 30 million easels, you're going to go up one grade. So we're starting at a 64, so we go up one grade. So
To
we're
a
at
70.
we go up to a 70, right? So here we are at the traffic speed. If you're less than 40 miles an hour, or you have a lot of stop and go, in other words, the traffic is stagnant on the pavement, we go up another grade. So we're up to 76, right?
Yep.
If we're in the pavement layer, we talked about the pavement layer. If we're in the subsurface pavement layer, we take away a degree. So we're back to a 70, right? Yep. And then, of course, if you use binder, we want to make sure that we don't over stiffen. Again, don't over stiffen. And so if we use more than 15% recycled binder, you subtract another grade. So you're back to a 64. Mm-hmm. Okay. So thinking through that, the main thing is that it's that traffic volume going up 2 grades if you're over 30 million easels, and then what the traffic speed's doing to you. Okay. So that's real important. Adjust up to 2 grades, no higher than a 76 or no lower than a 64.
Yeah, we don't want to go overboard.
We don't, because to be able to modify this liquid asphalt, it's going to cost you more money. Okay. So if you're on a farm to market road that has less than 10 million easels and you're doing 50 miles an hour and it's the surface mix, we're going to use a 64. There's no reason to spend the money to be able to put a 70 or 76 there, as well as if it's in the subsurface level. If it's down below, there's no reason to use that modified oil down below. It's just a waste of money. What we want to try to do is use it up on the surface, okay? On the low end, the minus end, again, our base grade is a 64 minus 22, okay? So again, because we're dealing with cracking, we're not dealing with rutting, the traffic volume and the traffic speed really don't come into play.
Right.
What comes into play is where it's at in the pavement structure and how much recycled material we have, right? So you can see that you're going to add 1 grade if it's a subsurface, and you're going to take away a grade if a recycled binder is greater than 10%. But again, not to go any lower or any higher than that 22, 28, right? That makes sense?
Yeah, absolutely.
So this chart right here, again, not only do we have it on our website, TxDOT has it on our website, but it's so useful. It is so useful. And what we're trying to do is put the right material in the right spot to give us the longest lasting, most durable pavement structure. That's the bottom line here. And so for you to be able to do that, you've got to know your traffic volume and your traffic speed. You got to know where you're placing it at.
Yep.
Okay. And we don't want to waste money. But we do know this. If we do this correctly and we get the correct aggregate structure, we're going to have material that's going to be durable, long-lasting pavements out there. So anytime somebody says, well, asphalt just can't hold up, where they're not utilizing it correctly, they're not looking at the information correctly. Asphalt can hold up. It can support the weight. It can be perpetual pavements. We've proven it. We just got to use the right material in the right spot, right?
Yep.
That's the main thing. Okay. And again, why do we want to do all this? It's because of consistency. Okay. We want to be consistent. We want to be consistent with our materials, our aggregate materials, right? We want to be consistent with our oils. We're real heavy into testing of our liquid asphalt. Okay. Materials and Test Division test the living heck out of our liquid asphalts. And that's not only for the asphalt, for asphalt pavements, but also for seal coats. Liquid asphalt is being tested considerably more than it ever has been. And we're really paying attention to our liquid asphalt. We're paying attention to the reobs, not using reobs in our mixes. We're paying attention to the PPAs, which again is a modifier that we're not allowed to use more than 5%. We're paying attention to the properties, and we're also paying attention to the base grades and how we're getting the base grades. Are we getting them imported? Are we bringing them, from overseas? Are we refining them? All those come into play, but the more data and the more information that we can get with our liquid asphalts, the better that they're going to perform. Jim, I know that the major associate members of TXAPA, which is all the liquid asphalt suppliers in the state of Texas, they're members here, and we've really paid close attention to their needs and to TxDOT's needs. I've been very active with the Quality Initiative Committee. Again, we have members from industry and members from TxDOT looking at different ways that we can increase our durability, increase our consistency, maintain safe roadways. It's all about safety and quality.
Yeah, there's been just so much work done on binders in the last year and a half or so, all the way through COVID, and before, starting with the increase on the sampling and the testing to make sure that we're doing what we're supposed to be doing in the field, doing additional education on that. There's a lot of work being done with the binders. And rightly so. Like we talked about earlier, we're asking that binder to do a lot for us.
Right.
And we just need to make sure that we're getting it. So, yeah, kudos to our major associates for stepping up to the game. Big thanks to Materials and Test for all the work they've been doing and trying to test all those samples. And they've even got a binder dashboard that we could talk about if we had some time, that's available where you can go online and actually see how the test results are coming. So, yeah, I mean, there's a lot of good stuff happening.
And
hey, nice picture.
And more is not better. I just wanted to throw that out there for you that are out there that says, well, why don't you just add another % liquid asphalt and just more is not always better. If
that would solve the cracking problem, but not the rutting problem.
It would definitely solve the cracking problem. This is a Tom Mix. I love this picture. It's very indicative of what we can do in our industry. Again, it's a Tom Mix. It's a 76 minus 22. It's modified. And again, the reason why did we modify this? It's on the surface, right? So it looks like it's on a highway. It's on a surface. It's thin, pavement preservation, but it's going to be durable, long lasting. We have the aggregate structure. You can see the aggregate in there. So we have all the stuff that we talked about in the basics. We got the aggregate interlocking. We got a great liquid asphalt, keeping it together, gluing it together. Mm-hmm. And we're going to have a good, durable, long-lasting mat here for sure. A lot of people have seen this slide before. I love this slide. And what this slide tells us is as we're going down, as we get thinner in our materials, we're going to increase our asphalt content, okay? Again, we talked about this in our aggregate, that the smaller the aggregate, the higher the surface area, the more liquid asphalt we're going to need. But we have all the material here. We have our dense graded, we have our super paves, our SMAs, our PFCs, and our TOMs. And again, we have a lot of availability into just saying, use the type D 64 minus 22. Okay. It's okay to use that on a farm to market road with 4 cars a day or what have you. But if we need to, let's modify, let's get the super paves in there. Let's get our SMA, the Cadillac of mixes in there. Let's modify that material. Let's get our correct structure in there. And let's get our correct friction in there. And let's utilize that surface aggregate classification chart that we talked about a couple of weeks ago and that Richard Izzo talked about. Mm-hmm. Let's utilize the tools that we have in our toolbox to be able to produce durable, long-lasting pavements. And again, it's all about, we have the tools, we have the knowledge, we have everything available to us. That's what we need. Yes, sir.
Again, we want to put the right thing in the right place.
Absolutely.
And just like what you said, there's a lot of tools, and sometimes you got too many tools. You don't know which one to use. And so I think that's where, TXAPA can help, Materials and Tests can help, where you have questions to say, I want to do this here. Does it make sense? Just give me a reality check. And you go, yeah, it does make sense to maybe use that there, or maybe not, and this is why. Right. And so, so ask the question. We encourage you guys as you're making decisions about this or thinking about using a certain bind. Ask the question. Does it make sense? Is this the right place to use it? Is it the right thing to do? And so, yeah, good stuff, Chuck.
And design, again, you designers out there, design for the conditions. Don't design for the budget. Okay, I can't stress that enough. A lot of times I look at roadways that are prematurely failing, and again, we just didn't have the money to do the correct repair work. We didn't have the money. I get it. We do have money constraints, but let's design for what we need, or let's build and design for what's required and not based to a budget. Yes, sir.
Yeah, your pavement decision should not be dollars or your dollar budget divided by the lane miles that you have. That's not the right pavement thickness. Want to make sure we do it right. So yeah, do the right thing. Do the right thing. If you do the right thing with the roads you got, you won't be back as quick trying to fix them, and you can spend the money wisely on the other pavements where you really need to.
Absolutely. And again, at TXAPA, we're dedicated to quality. And again, we are partners in quality with our industry members, and then with our owners, TxDOT cities and counties. And I do love Michael Lee's statement that let's be safe. Okay, let's think about safety, and then let's think about quality. And if you're thinking about and you're putting quality or safety first, and then quality, guess what? Your production's going to go up, and you're going to gain more bonuses out there in the field and at the asphalt plant. And Michael Lee is exactly correct. If we concentrate on safety and we concentrate on quality, we are going to get more durable, longer lasting pavements. Our production rates are going to go up, and we're going to get more bonuses out in the field. And, the traveling public's going to be the end result with that. And, they're going to have smoother, quiet pavement structures to drive on. And again, I can't stress that enough, is that do the right thing, use the right tools, and kind of go from there. So, Jim, that's essentially it. That's my basics. Again, I didn't get into the weeds. I didn't talk about Delta T sub C or the aging vessels or any of that DSR or any of that other stuff that you guys
come on, Chuck. Give me some DSR action. Yeah. There we go.
I tell you what, I tell you, I just get blown away with some of these guys that have this knowledge. Oh, Ryan Barbarack and Travis Patton and Anand, you guys, oh my God, you blow me away with all the stuff you have up inside your head. But the basic is you need a little liquid asphalt, you need a little glue, you need a little rock, and you need a little air, and we're going to have some good, durable, long-lasting pavements by doing the right thing. And again, we have so many smart people out there. If you have a question, you need some help, please do not hesitate to call Jim or I will be, you notice I put Jim first.
Yeah, I noticed that.
Call Jim first and then me, and we'll get you in the right direction. And again, we have a lot of tools in the toolbox. And with that being said, one of the tools we do have is materials and tests.
Absolutely.
We have Travis Patton and Ryan and Anand and those guys over there and Miles Garrison. I can't stress enough, those guys not only have industries back, but they got TxDOT's back. So let's utilize all the tools we have and go out there and let's produce and place some good asphalt.
Yeah, absolutely. Safely, absolutely safely. Hey, big thanks, Chuck. You did a great job today. Again, we'll continue with our fundamentals, diving a little bit deeper next time into binders. And we'll pick up with Robert Lee's a little bit later on. We've had to do a little shuffle because of Snowvid, but we will get that sorted out. So in the meantime, be safe out there. Take care of yourself, and let's get over the Snowvid, the COVID, and get back to just normal. So take care, everybody. We'll see you next time.
Thank you, Dan.